Hello everyone, I am Masood Ibn Abdul Wahid. Today in this video we are going to discuss about some university question paper problems. The topic from which problems was taken for today's discussion is superposition theorem. As you all well aware that the statement of the superposition is this one, which says in any linear multi-source complex circuit, the voltage or current in a particular resistance will be equal to the algebraic sum of voltage or currents in that particular resistance with the consideration of one source at a time. All the other sources will be turned off or made inoperative. The process of making inoperative means short circuiting the voltage sources, leaving behind its internal resistance, and open circuiting the current source, leaving behind the internal resistance if it is given so. We will take a circuit to discuss the essence of this theorem's statement. So the given problem says find the value of I in the given circuit, and the given circuit is this one, which has a resistance with two sources. One is voltage source where the other is a current source. So now as per superposition theorem we have to consider one source at a time. So let us consider the battery 5 volt alone. For that we have to make the current source 3 amps inoperative, which means we have to open circuit the current source what given in the network. So by open circuiting the 3 amps, the circuit can be redrawn as given to you here. By doing so, the total circuit will become an open circuited path. So as we all well aware that there will be no current through an open circuited path. So the current through the 5 ohm resistor, which is considered to be I1 in this circuit, is 0. So by considering the current source alone, we have short circuited the 5 volt battery and we have redrawn the circuit. So by seeing the circuit, there is only one current source and there is only one closed path. All the current delivered by the current source will be flown through the 5 ohm resistance. So in that case, we can write the current through 5 ohm resistance, which is marked to be I2, equal to 3 amps. So what we have done so far is we have considered one source at a time and we found the current through 5 ohm resistance individually. Now according to the superposition theorem principle, we have to do the algebraic summation of these individual results to get the total current through the 5 ohm resistance, which is done as given to you here. So current through the 5 ohm resistance I is equal to I1 plus I2, which is equal to 0 plus 3, and the total current through the 5 ohm resistance by considering all source at a time is equal to 3 amps. So this is how we have to use the superposition theorem to find the voltage across or a current through a particular circuit element. So now we will go into the Proteus and plot the given circuit. The given circuit was plotted in the Proteus software with an ammeter included to read out the current through 5 ohm resistor. Just by running the simulation, the current through the mentioned 5 ohm resistance is 3 amps in the software simulation, which is correlating with our manual calculation. So now let us take another question which is from the same university question paper. Find V using superposition theorem for the circuit shown in figure, which is having voltage source, a current source. So these two are independent sources, whereas this one, it is a dependent voltage source which will depend on the voltage across this 3 ohm resistor, because they mentioned that this 3 ohm resistor, the voltage across the 3 ohm resistance is mentioned to be V and the source voltage is mentioned to be 2 times V. So there are two independent sources and one dependent source in the network. And we have one in each case, that is independent voltage source, independent current source, and a dependent voltage source. So now for finding the mentioned voltage across the 3 ohm resistor, we have to use superposition theorem, for which we have to consider one source at a time. So here one source at a time means we have to consider one independent source at a time. We have to keep the dependent source all along through the solution. Let us consider the network with 4 volt battery alone. So by redrawing the circuit, by having only the 4 volt battery, the circuit will be as shown to you here. So we have open circuited the 2 amps current source, and in this we have two meshes. So we will have two mesh currents, I1 and I2, in this way. And we have to find this I1 and I2. To find that, we need two equations as there are two unknown currents. For writing the loop direction, let us consider some node namings. Let the node namings be as mentioned here. So here the first mesh or the first loop will be A, B, C, F, G, A. So as you remember, we have done the solution using mesh analysis in the previous video. So we have to consider the loop direction and the assumed current direction, and we have to write the loop equation. So if both the directions are same, it is potential drop. If both the directions are of opposite, then it is potential rise. So by considering that, let us travel from A to B. If you travel from A to B, there is a 3 ohm resistor. The loop direction and the current direction are same, so it is minus 3 I1. And when you travel from B to C, we have a 2 ohm resistor for which the loop direction and the current direction are same. So this is also a potential drop. And when you travel from C to F, we have a 5 ohm resistor in which there are two currents. Both the currents are in the same direction, so we can take the 5 ohm resistance current to be I1 plus I2. Now, considering the loop direction and the current direction, both are in the same direction, so it is potential drop again. So minus 5 multiply I1 plus I2. And from F to G, there is nothing, no elements. So from G to A, there is a battery for which, according to the assumed current direction, the current is going from negative to positive polarity of the battery internally. So it is a potential rise. So we have to write plus 4 is equal to 0. We can simplify the equation as shown to you here, which is our equation 1. Now going into the second loop will be DCFED. In this, we will go from D to C, where the loop direction and the current direction are in the same way. The potential drop will happen in the 1 ohm resistor, so minus 1 I2. And from C to F, we have a 5 ohm resistor, and the current through the 5 ohm resistor is I1 plus I2. As the loop direction and the current direction are same, here also there will be a potential drop for which minus 5 multiply I1 plus I2. And when you travel from F to E, there is no elements, and from E to D, there is a dependent voltage source for which, according to the current direction, the current is flowing internally from minus to plus. So it is a potential rise of voltage to V1, which is equal to 0. So now the voltage V1 can be calculated from the given circuit as V1 is equal to I1 multiply this resistance value, which is 3. So the voltage V1 will be equal to minus 3 I1. So the minus comes because the travel direction and the assumed current direction are same, so there will be a minus encountered. So when you change this V1 to be minus 3 I1, the equation will be changed as given to you here. And now let us separate out the I1 terms, I2 terms, and if you simplify the equation and write, the equation will be this one, which we can mention it to be equation number 2. We have two equations now. So by solving these two equations, we will get the currents I1 and I2. So I1 is equal to 4.8 amps and I2 is equal to minus of 8.8 amps. As you all know that the minus sign in the current I2 indicates the actual current direction is opposite to the assumed current direction. And by using this I1, we can calculate the value of V1 as V1 is equal to minus 3 I1, which is equal to minus 14.4 volt. So far we have considered the 4 volt battery alone, and we calculated the voltage V1, which is across the 3 ohm resistor. So now we are going to consider the current source alone. For that, we will redraw the circuit by considering only the current source. So we have short circuited the 4 volt battery, and by doing so, we will get 3 meshes or 3 loops, one here, another here, another here. So we will get 3 meshes. So we will use node analysis method to find what is the voltage V2, so that we need to use lesser number of equations rather than using mesh analysis with more equations. So for that, let us consider the nodes. So let us assume this is node A, this is node B, and this is node C, which is the reference node. As you all know that in the nodal analysis method, the voltage of the reference node will be taken to be 0. So now at node A, let us assume the currents as given to you here. So at node A, the current equation will be given by the incoming current is 2 amps. So 2 amps will be equal to I1 plus I2. So let us rewrite this currents I1 and I2 in terms of node voltages by writing we can write it as 2 is equal to the I1 is going from the node A to node C. So the I1 can be written as VA minus VC divided by this element 3 ohm. So that is what written here, VA minus VC divided by 3 plus I2, which is going from node A to node B. So I2 is equal to VA minus VB divided by this element 2 ohm. So that is what written here. The voltage of the reference node is 0, which is VC is equal to 0. By putting VC is equal to 0, the equation will have a slight change as given to you here. And in this, by manipulating and simplifying the equations and separating out the VA term and VB term, VA and VB are separated out and we have written this equation. And in this equation, we need to know that voltage at the node A will be equal to the voltage V2, because V2 is collected at this point and VA is here. So the V2 is nothing but the voltage VA. So here we can write the VA to be V2. So by changing VA to be V2, we can rewrite the equation as given to you here, which is the equation number 1. We are writing so because the voltage VA is nothing but equal to the voltage V2. Both are same. So now we will write the current equation at node B. So at node B, the current equation is I2, which is the incoming current, equal to I3 plus I4. Written here. We will write the current values in terms of node voltages. So I2 is equal to VA minus VB divided by 2 equal to I3, which is VB minus VC divided by 5. The current I4 is VB minus this dependent voltage source divided by this 1 ohm. So this is what written here. So again in this equation, the reference node voltage VC, we can make it to be 0, so that you will have a slight change in the written equation as this. So here we will separate out all the VA terms and VB terms and we will rewrite the equation as shown to you here. So in this equation, once again, the voltage V2 is nothing but VA. In this, the voltage VA is nothing but V2. So you can change the term VA to be V2 by changing. So we will have a slight change in the equation as this, and we can add this V2 terms together. So by adding it, you will get the equation as shown to you here, which is equation number 2. So we have two equations now. By solving these two equations, we will find the two unknown values V2 and VB. So the V2 is equal to 20.47 volt and VB is equal to 30.1 volt. So far what we have done is, we have considered one independent source at a time and we found the voltage across this mentioned 3 ohm resistance 2 times. Now according to superposition theorem principle, we have to do the algebraic summation of these two answers which we got by considering one source at a time. So with 4 volt battery only, we found that voltage across this 3 ohm resistance as V1 is equal to minus 14.4 volt, and with 2 amps current source alone, we found the voltage across the same 3 ohm resistor as V2, which is equal to 20.47 volt. Now as per superposition theorem principle, we will do the algebraic summation of these two answers to get the total voltage across this 3 ohm resistor, which is equal to V1 plus V2, which is minus 14.4 plus 20.47. By doing the manipulation, the voltage across 3 ohm resistance V is equal to 6.07 volt. So we have got this answer through manual calculations. Let us, as usual, plot the given circuit in the Proteus. As you can see here, the circuit is partially plotted in the Proteus. So the only remaining thing what we have to add is, we have to add the dependent voltage source here. As it is a new element, I will show you how to pick the device and then how to draw it. So go to the component mode, go to pick devices, and here type as voltage control voltage source. In short, you can type it voltage control voltage source. So it is VCVS. So this is the voltage control voltage source we are in need of. We will pick this, and you can click one time and click one time inside the plot area. So place it here. So now you can complete the circuit connection. Okay. So we have completed the connection, and the given voltage sources of the dependent source is having a voltage of 2V. So we have to change this one as 2. Okay. Now the voltage of this source depends on the voltage across the element. So we have to connect these two terminals across the resistance 3 ohm. So take the plus, connect it with this side, and take the minus, connect it with this side. So now the circuit is fully plotted as given to us, with only one extra thing. We have inserted a voltmeter to read out the voltage across this 3 ohm resistor. So now we can run the simulation and started the simulation, and you can see here it is 6 volt, which is correlating with our manual calculation. So we found that the manual calculation is correlating with the software simulation answer. And in today's video, we have discussed about the solution of unionized question paper problems. And the topic we took for today's discussion is superposition theorem. So we have discussed about the statement of superposition theorem, and we have solved 2 problems, out of which one is very simple one and another is a big question. And we have correlated our manual calculation answers of both the problems in the Proteus simulation software. So hope this video was useful to you. We will meet in our next video. Until then, it's Masood Ibn Abdul Wahid signing off. Thank you for watching.